Good to go.
Can everybody hear us all right?
Oh,
Give us
Okay.
a nod.
Okay.
Yes, thank you.
Nice.
yay.
This is a very weird setup.
It is a bit.
Okay. Take it away.
Oh no. Can I? Next. Oh, I have to click. Cool. So hello, we are Live.js, a collective of artists who build software using JavaScript, which usually runs in the browser. I'm Sam,
I'm Ruth.
And I'm Jan.
and there's three
I'm
other
Jan.
members which aren't here today, and they are Matt, Martin, and Tim. So our shows and performances usually look something like this, and you may have seen us perform this morning. This talk will show you how we use the web to perform live, and how we created the introduction to Codemotion. So to start off, we have Ruth.
Hi. Go on.
Switchy switch.
Awesome. Hi, I'm Ruth. I usually do the visual stuff. I'm a visual artist. So the software that I build is based around making visuals to music. About 5 years ago, I started building Visra, which is my software. It's built in JavaScript, and it runs in a browser. When I started, it was an extension of a few years of experimenting with things like the Web Audio API, Canvas, that kind of thing. And so I tried to make this big piece of software that could do everything. It could do audio analysis. It could draw things onto Canvas. I was working with SVGs, DOM elements, video, and it just got too much. So at the beginning of this year, I just tore it apart. Now I have multiple pieces of software rather than one piece of software. I have one that does sort of generative art with visuals. The one that you saw this morning mostly just works with video. So I'm just basically working with video clips. It's pretty simple, really. You've got two video elements sitting in the DOM, just like that. And then I mix them using the Web Audio API. Now, Jan is going to talk more about the Web Audio API in a minute. But for this part, I'm just going to mention the analyzer node. So the Web Audio API can analyze sound. Now, it does this by giving you back the velocities of the frequencies of music. Now, if you don't understand any of those terms, it's OK. The velocity is like the volume. It's kind of like the loudness of the music. And the frequencies are the sounds from low to high. So at any given point in the music, I can have a data which tells me the volume of the low and high sounds. And that's what I use for all my visuals. It's just data points. Demo. So I have, now let's see if this works. Oh, no, hang on. There we go. So everybody see that OK? Great. I built an audio visualization starter kit. It's on CodePen. You can Google it, Audio Viz Starter Kit by Rumira. And it's basically that. It's a pretty easy way of getting yourself set up and like making your own visualizations. I have a couple of nice ES6 modules going on. So there's an analyzer module here. It's a nice little class. That basically deals with all, like pulling in that analyzer node and then working through the frequencies and exposing it. I extend that out into like a Viz class, and then that deals with like a request animation frame and a draw function, and then that's what you call when you want to create a new visualization. I'm not going to go into the code in detail now. I don't have enough time, but you can go and have a look at it in CodePen. So this is a really simple example. I'm just creating a new viz. I'm setting how many points of frequencies that I want in that viz, because you can do however many you want to. And then just I'm looping over the frequency data that I'm getting back and creating elements for each of the frequency data. So, any luck? There we go. Can I get some music? Oh, we don't have any music. Thank you very much, Jan. So that's picking up on my microphone and basically just analyzing it. And it's just a bunch of I elements in the DOM, and I'm just changing the width of them depending on that data that I'm getting back. So that's a really, really simple example. But you can do whatever you want with these numbers. In the starter kit, there's an example of using SVGs, an example of using Canvas, and there's this really simple HTML and CSS starter. I've lost my mouse. There we go. So that's fine for the video stuff. So I can mix these two video elements that I have. Basically, I just have a threshold value. And if the sound level goes over a threshold value, I just show and hide these two video elements. So you get like a really nice mixing effect for them. But I also need to swap out video sources, right? I've got lots of different videos that I want to show you, and I need a good way of doing that. I do it with this pad of buttons here. This is my MIDI controller. So a little word about MIDI. Thank you, slide. This is a MIDI controller, and we get it in the browser with the Web MIDI API. Now, it's not hugely supported. It's Chrome only in other browsers like Chrome, so Samsung Internet, Opera, soon to be Edge. It's not all browsers, but it gives you a bit of data when you press buttons on a MIDI controller. MIDI, I know what you're thinking. You're thinking those bleepy 80s music from like web pages back in the 90s. It is a file format, but essentially it's just a data protocol. Back in the 70s, they had a rise of popularity around electronic instruments. So there was lots of synthesizers, drum machines. So a bunch of industry experts and music instrument manufacturers got together at the beginning of the 80s. And they thought it'd be really nice if they just had a protocol for all these bits of hardware to be able to talk to each other. And also talk to other equipment in the recording studio as well. And that's when MIDI was born. It's been around ever since. So we have access to this in our browser. By the way, the lights just dimmed as I got to that bit.
Spooky.
Woo. And this is what we have. So we have things like MIDI instruments, which are usually like you probably played an electronic keyboard, like the musical kind of keyboard. That gives you a sound when you press it. Most keyboards these days are MIDI enabled. So if you plug them into your computer, you'll be sent a MIDI message. This is not a MIDI instrument. This is a MIDI controller. It doesn't have any onboard audio. If I press the buttons, I don't get any sound unless I make it make sound myself. If I but it does send my computer MIDI messages. Where did we get to? So this is basically the data that you're getting in a browser when I'm pressing buttons, right? So this is using the web. This is a really simple example of the Web MIDI API. And I'm just pressing these buttons, and this is the data that you get. You get sort of 3 numbers. One of them is saying what channel it is, like this is this thing. The next one is saying it's this note. So essentially, it's this pad that I'm pressing. And if you do get a third value, it's usually a velocity value, like how hard you're pressing the button, which your controller may or may not have. And then you have like different sort of what we call continuous controllers, which means that you can actually sort of, it's usually the dials and the knobs that you see on other things. On this one, it's just a pad, so things like this. So you can do things with those numbers. So what I can say is, when I press this button, I want to show this video. And basically, I'm just swapping out the video source. I can also do sort of basic, I'm going to flick over this, basic effects with CSS and things, because it's the browser, right? So demo. There is a code pen for that as well. It's probably easier if I share this after the talk. But that basically makes up the crux of what Visra Vid is, which is just these 2 video elements. If I go back over here and do that. So this is what you saw this morning. And it's basically just these 2 video elements playing and hopefully sort of mixing when we get some noise, although my threshold values are very hard at the moment. I know, it's difficult. It's all right. We can do some cool effects. She said, I think my... Yeah, there we go.
Oh, nice.
Nice CSS effects going on there. Nice little invert. And that's basically the whole crux of it. Over to Jan, who is going to talk about music.
Wait a second. That's where I wanted to go. Hi, I'm Jan. I'm just here for the music. Unfortunately, I can't really show you the music because the audio connection is not working for a trillion of possible reasons. Couldn't get that to debug. It was working this morning, as you've hopefully heard, so that's good. The sound you've been hearing this morning was entirely generated by JavaScript in the browser. And the composition was actually done in Ableton Live, which is a music composition and production software that you've probably heard about. And it was just easier for me to work in a tool that I know very well and then transfer it to the web technologies. So essentially, you have something like this where Ableton is sending MIDI data, which Ruth just talked about, to the browser via the Web MIDI API, and then I create sounds using the Web Audio API. The software looks like this. Very impressive. I can see how awed you are by its UI. And that's because it doesn't need to be more. It's faceless. It's just producing sound. It's the third generation of this tool. Matt, who was mentioned earlier as one of the members of Live.js, and I built this for JSConf EU earlier this year. It was called Dominator by then. And then for JSConf Asia in Singapore, Matt evolved it into Baseline 4.18. And for this event, I built another clone of it, which is called SL1201. And if you know a little bit about the moon landing procedure, specifically error messages, you probably know where that name comes from. So it's built using the Web Audio API, and as Ruth said, I'm going to expand a little bit on that. Just out of curiosity, can you lift up your hands if you've ever worked with a Web Audio API? Okay, that's not a lot of hands. That's good. So I'm not telling you things you already know. The Web Audio API is a piece of API in the browser that is widely available. It's available in all modern browsers for sound generation, analysis, and modification. It's a graph-based API, which is a fancy term for you can plug things into each other. So it looks a little bit like this, only with less cables. But you can think of it in the same way. So you have nodes, which are probably something like classes, and you can connect them to each other, and you can build a graph that essentially gives you the flow of audio data in the system. You have the audio context, which is the overarching entity that you use to create these nodes, and that gives you the output to the sound card and everything. And then you have all kinds of different nodes. They are all pretty well documented in the spec. So you have things like the oscillator node, which just gives you a sound source. It could produce a sawtooth, a square wave, a sine wave. And you have filter nodes, which allow different types of filters, which allow you to cut out several different parts of the frequencies of the sound. And you have things like the gain node, which allow you to shape the amplitude or the loudness of the signal. And with these three nodes, you can essentially build sort of an emulation of an analog synthesizer. And on the bottom, we have another example. The buffer source node allows you to play back samples. I've been using this morning for the drums, for example. And then you have this concoction of the delay node, a couple of gain nodes, a filter node to give you a very nice filterable delay effect, which you've been hearing as well this morning. And everything is just connected to the output of the audio context, and thus you can hear it. This is a bit abstract, so let's do sort of the hello world of audio, web audio code. So you create a new audio context, you create a new oscillator node, you create a filter node, you create a gain node, and then you connect everything together, essentially as I've just shown you in the graph. And then you can just start the oscillator and stop it. That's very important to stop it again, otherwise you will be annoyed pretty quickly, especially with your first few experiments, because it's going to sound really shitty. And so the way this works is the audio context gives you a time base, and so you can schedule things into the future. And this is very helpful, because if you would only be able to play static sounds or apply static effects, that's not going to be very musical or very artistic. And so you can use these parameters of the different nodes to shape things over time. And if you think about this triangle that I'm drawing there as like a continuation of different values on the frequency parameter of a filter, for example, you can use these method calls to make that happen in the future. Which is pretty cool, because this means that you don't need to rely on JavaScript's pretty bad timing functions, for example, to get to tight audio timing, because you can just schedule things into the future, and they will be, since it's all C++ code, it will be on time. Obviously, in practice, it's going to be a little bit more complicated than the simple example. So this is the relatively simple poly synth I was using earlier today, and it's the setup code for just one voice. And so you can see it's a lot of code. It's very verbose. Yeah, you can look at it. It's open source, so I'm going to skip over this. I'm going to skip the demo because there's not much to demo here. I can show you. So this is the actual song in Ableton Live, and you can see all these black dots are essentially notes. So if I'm going into here, somewhere there should be notes somewhere. There you go. And these are going to be played back via MIDI to the software, which is sitting over here. And if I'm reloading this, and I'm going to start, let's say, here. You can probably hear a little bit if I put this down here. So that's part of the song. That's all I can show, unfortunately. So this is the URL to the GitHub repository if you want to take a look at it. I think it's still relatively simple. And the last thing I want to talk about is why, because Ableton Live is a pretty complete environment, and together with commercially available instruments you can buy for Ableton Live, you have this perfect environment where you can create pop music or electronica or what have it very, very easily. But for me, building my own instruments, so to speak, is a very important part of my artistic expressiveness in a way, because I can shape the instruments in exactly the way I want them to be. And I think that's very important. And since I am able to do that because I'm a web developer and the API is relatively easy to understand, I can build my own tools. And I find that very important. And with that, I give over to Sam, who's going to talk about the other part of the visualization.
Thanks, Jan. So I'm going to talk to you about ModV, which is an open source audio visualizer and VJ performance environment I've been developing for about 6 years now. It's coming up for that. It's available through modv.js.org, and there's documentation there. And so if you need any more information, it's just that URL. This is ModV's current interface, which might look a little daunting, but it's probably because I'm not a UI designer, so it's a bit messy, but it works. And this is usually ModV's kind of output. This was at JSConf last year on their huge setup, which was very nice to play around with. It consumes the same APIs that both Ruth and Jan have talked about, and it also uses Canvas and WebGL, amongst other things, to produce the visual output. And to allow others to use this software, I've created an ecosystem around plugins and modules for ModV. So I'm just going to show you the ModV ecosystem very quickly in the form of writing a module for ModV. So I'm just going to hit the mirror display button, and hopefully nothing breaks. Yeah, that's all right. OK. So yeah, this is directly from the site. So if you want to follow along this guide later to create your own module, you are very welcome to do so. So a quick show of hands. Who's ever used Canvas before? Oh, not many. OK, so Canvas is a drawing API in the browser, which lets you create a bitmap and then draw to it. And you can keep drawing to it and change stuff, and kind of you can draw canvases onto other canvases. It gets very messy very quick, but it's very fun to use. It's basically just pixel pushing in the browser. So the default 2D module in ModV uses the Canvas API, and to get started, you just export an object, just a blank object. Then you add some data to it. So you tell the object what type it's going to be, or the module what type it's going to be with 2D. You just give it a name as well, because you need to find it in ModV. And this is where the drawing code comes in. So it's not too bad. So ModV gives you a canvas and a context of that canvas as well. The context is how you draw to a specific bitmap once you've got this. And the bitmap is the canvas here. So we're telling the context to draw red. And we're just going to create a path. In this case, we're drawing an arc, which is a circle. And we're going to place it in the middle of the canvas. So the width of the canvas divided by 2, divided by the size of the circle. And then the same with the height. So that places that directly in the middle of the canvas. We give it the size. We tell it to start drawing at 0 degrees and go all the way around to create a full circle. and then we tell it to fill. Now in ModV, this gives us a little red circle, which is quite nice. Looks great. But I told you it was an audio visualizer, right? So this is where properties come in. So like your web components, like modules, you have the ability to define controls or properties. So this module can take in a size property. And in ModV, it will render a small control, which says size, and you're able to drag this up and down to change the module size. So once we've got a size defined with type integer, you just give it a default, minimum, maximum, absolute value as well. We've also got a color property as well on this. And we're just going to do a slight edit to draw. So instead of defining these specifically, these properties, which we've defined here, are now on the module's instance, or the scope, sorry. So you can access them through this. And that gives us some controls. But it doesn't really make sense for me to just show you some code. We'll see what ModV actually does. So hopefully you can all see this. Great. So this is our output of ModV here. So we have a gallery full of the modules that are available to you. That's my face. Hi. And you can just drag and drop them over to the left-hand side here. So we can put the webcam over here. Nice. So we've got the text drawing at the moment, so we can say, hello, Codemotion, and maybe make our output slightly bigger than that. There we go. So these are the properties that you can define in the module here. So our size would have rendered out like this. So just by defining size in the property gives you a control to modify whatever you're drawing. This is the simple 2D module, but ModV allows you to write shaders, which run on the graphics card, and a few other different module types as well. If I show you the preset that we used for the intro this morning, I'll just load this one up. I've got a MIDI controller plugged in here, and it should hopefully have saved all of the bindings from this morning. There we go. So bring it up. We'll bring the wobble up, and we'll turn the wobble on. That's pretty nice. So we can bring up this special 3D printed one here to really distort that. And these are just bound to the opacity of each module on the side here. So if we focus on luminosity, when I bring this up and down, see the value going up and down here. So this also does react to music. I'm going to play the demo file if that's all right. Yeah. So we'll just play some music here. And hopefully, it should be listening. If it isn't, it's all broken. Let's put it on the ear. That'll help. And then we'll also just turn the scaling up slightly too. So yeah, there's a lot of features in ModV which I can't cover in this very short talk, but you should be able to find a lot of stuff out from the documentation now. So we should have some music. There we go. You can see it's slightly bouncing to the beeps. And we can mix in some other stuff here. So we have a couple of shaders that were on Shader Toy. One is this galaxy, which is very nice. I didn't write that. The Codemotion circles, which I did actually write. So they're on in the middle there. We've got a bit of a nebula. Again, I didn't write the nebula. And we have some countdown as well. Nice. So that's an extremely short look at what ModV does. It's it's kind of getting a bit large now. So if you want to contribute to that and fix some issues, that would be perfect. So next up, we're going to talk about our opening.
Yeah, so we want to take the last few minutes to talk a little bit about the opening and how we approached it. So we got the brief, which was, OK, Codemotion Milan is going to be about the 50th anniversary of the moon landing, which is a pretty cool thing. I personally was born after the moon landings, pretty much after any of them. Anyone in here who has seen the moon landings on TV?
Reruns.
Trick question, yeah. And so, yeah, so the theme was space. And we wanted to focus on the preparation of the moon landing, but also the time after the moon landings, how space exploration has evolved since then. And we knew that we had a time limit of 10 minutes. And so we were just trying to throw together a storyboard. And like in the beginning, it was more like a mood board kind of thing, where you're just throwing in images and videos and sound ideas. And so, everything from the first Sputnik launches, which you can hear in the beginning. If you haven't recognized the beeping in the beginning, that's the one of the signals Sputnik was sending, the first satellite in the Earth orbit. Then Laika, the first dog in space. Yuri Gagarin, who was the first human in like an orbit around the Earth. And then all the way to the moon landings and all the preparation that got into it. And if you've been listening to Don Ailes this morning, you know a little bit about what went into that. And but again, we also wanted to show like what's been happening since then. And we try to kind of reflect that also in the music. So in the beginning, it is a little bit like psychedelic rock-ish kind of thing. Maybe you've recognized the beat if you're an avid Beatles fan, for example. And and then it was really just a case of throwing all of this together. We spent one weekend essentially trying to figure out what kind of elements we want to use. Ruth researched all the videos. There's lots of awesome video sources online. YouTube has a lot of NASA videos, for example, and all of that stuff. Sam was looking into what kind of effects would work with the style of the different time periods and everything. And the thing about this performance is that most of it is improvised on the spot, even though we use like canned material, like videos and effects that have been prepared, but we actually schedule them on the fly. And so if we were to do this again, say now, which we can't because we don't have the tech here, it would be at least slightly different because it's improvised and done on the spot.
Thank you. You can find us. Very much. You can find us online. We do have a website, livejs.network. On that website, there is ways to get in contact with us. We have built a community around this, so we take questions about web audio, MIDI, Canvas, all the stuff that we do. So there's a Slack channel on there. We're at livejs_network on Twitter. These are all our Twitter handles. There is obviously more to the group as well. So please join our community if you fancy it, if this is something that you're interested in. And I believe that we have some time for questions.
If it would be possible to take questions.
I don't know how that works.
Yeah. Any questions? Okay.
Oh, he explained that so well.
No, I'm not sure if they know how it works either.
Great.
Okay.
Well, if there are no questions.
Well, we'll be around for the
We'll be
rest of the day, so come and have a chat with us if you want to.
Perfect.
Okay.
Thank you very much.
Thank you very much.